Hey, welcome back to your favorite trigonometry class. We're going to look at graphs of the tangent, cotangent, cosecant, and secant functions today. So first of all, let's start out with our tangent function. Okay, so if we let f of x be the tangent of x, which we know as the sine over the cosine. The first thing I'm going to do is I'm going to think about where is this thing undefined? Where is it undefined? In other words, where are my vertical asymptotes? Vertical VA, vertical asymptotes. Where is this thing undefined? Right? Well, we know the denominator can't be zero, so we're really asking the question, where's the cosine equals zero? Cosine of what is zero? We know the cosine at pi halves, right? We know the cosine of pi halves is zero, right? We also know the cosine of 3 pi halves is zero. We know if we go around once to pi halves, in other words, 5 pi halves, we know that the cosine of 5 pi halves is also zero, and so on. So that's what we're thinking about here. Whoops. Is I'm like, all right, pi halves could be x. So I know I have a vertical asymptote at x being pi halves. I also know the cosine of 3 pi halves is zero. So I have another vertical asymptote at 3 pi halves. I know the cosine of 5 pi halves is zero, and so on. I didn't even go, and this keeps going. But I also know the cosine of negative pi halves, right? Your cosine there is also zero. If I rotate negative 90 degrees, so cosine negative pi halves is zero. So these are plus minus, cosine of negative 3 pi halves, and so on. This is all plus minus, this continues. So I can generalize this. My vertical asymptotes then, notice it goes up by uh, pi each time, right? It goes pi halves and then 3 pi halves and then 5 pi halves. It goes up by pi each time. So I'm going to say that um, my vertical asymptotes is to generalize this. It's pi halves plus or minus pi k, where k is an integer. Okay, that's the general form for that, and that hits. So, like for example, our integers. Here's our integers, right? Counting numbers as well as zero as well as the negatives, right? So if we let k be zero, then according to this, we just have pi halves, right? There's the pi halves. If we let k be 1, now we have pi halves plus k times 1. So well, pi halves plus pi is 3 pi halves. Now we have that one, right? Now if we let k be, and if k is, well, I'll keep going here one more. If k is 2, now we have pi halves plus 2. We got our positive 5 pi halves. Now if our k is negative 1, now we got pi halves plus pi times negative 1. So pi halves minus pi, negative pi halves. Negative pi halves. There's the negative pi halves. If k is negative 2, now we got the negative 3 pi halves, and so on. So really, I don't even need the plus minus on that. I could just do plus pi k. Since I'm letting k be all my integers on that, I'm letting k be all my integers. Let me erase some of this so I can keep going. Okay, so I have my general form of this. I'm going to put for my vertical asymptotes, I'm going to go ahead and draw my graph. I'm going to go ahead, I'm going to put my vertical asymptotes on here now. Let me do that in red. So I have a vertical asymptote of pi halves, 3 pi halves. I know I'm not going to hit this. This is where it's undefined. I know I have it at negative pi halves. I know I have it at negative 3 pi halves and so on. Okay. So now what we're going to do, step 2 on this thing, let me erase a little bit, is I'm going to plot some points. So I found where it was undefined, my vertical asymptotes. I'm now going to plot some points. Let me start, and I'm gonna graph it. Let me graph it between negative pi halves and pi halves. Let me start out with 0, and then I'm gonna plot a few here: pi 6, pi fourths, pi thirds. Uh, Pi halves we know is undefined. You know, it's a vertical asymptote. It's undefined. Stop there, and then I'll go to the left of 0. So let's plug 0 in. So I have sine 0 over cosine 0. I know the sine is 0, right? I'm just, oops, oh my gosh. You know, I'm on my unit circle, I'm right here. Sine is 0, 0. Cosine of 0 is 1. So I got 0 over 1 is 0. Now I'm going to go to pi 6. Pi 6. So now I'm plugging in sine pi 6 because I'm finding the tangent pi 6, right? Cosine, which is sine pi 6 over cosine pi 6. We know sine pi 6 is a half. Cosine pi 6 root 3 over 2. So I got 1 over root 3 or root 3 over 3. So this is root 3 over 3. That's about 0.58. Plug in pi fourths now. Now I got sine pi fourths over cosine pi fourths. I got root 2 over 2 over root 2 over 2. So I got 1. I'm going to punch in pi thirds. And I get root 3 over 2 over 1 half. So that's root 3. That's about 1.73. Got my pi halves undefined. Let's plot those points. Okay, so we got 0, 0. And now pi 6 about right here. Pi fourths, pi thirds. So pi 6, I'm at 0.58. Pi fourths, I'm actually at 1 right here. Pi thirds, I'm at 1.73. Okay. Now I'm going to go to the left. And let me do negative pi 6, negative pi fourths, negative pi thirds, and so on. What you're going to see is I plug in negative pi fourths. So now I'm rotating down negative pi fourths. The sine of negative pi fourths is negative root 2 over 2 over positive root 2 over 2 for the cosine there. So I get negative 1. I could plot negative pi 6. I'm going to get negative root 3 over 3, which is negative 0.58. I'm going to plot negative pi thirds, and I get negative root 3 over negative 1.73. So I'm about right here. And then I'm just going to kind of smooth this out, do my best to kind of draw this tangent function. Okay, so that's your tangent. Let me erase. And then I would repeat that over here. I'm going to plug in sine of pi as 0 over cosine of pi is negative 1. So I'm going to plot that point. 0 over negative 1 is 0. Why isn't this thing drawn from there? There. Uh, Go ahead and plot 5 pi fourths. You'll get 1. Plot 3 pi fourths. You'll get negative 1. And anyways, you kind of continue plotting just like I showed you on the other one. Plotting points, punching it in. you're going to see that it repeats that same exact curve there each time. It's going to keep repeating, keep repeating. Okay. So your period is pi. From negative pi halves to pi halves is pi. So when you have a function of the form a tangent omega x, here our omega was 1, but just remember that your period is pi over omega. Okay, sometimes you might have a horizontal compression or stretch depending on omega. Okay, so your period here, 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 your period, and by the way, use capital T is what your authors use, is just pi. Okay, because it's pi over 1. So we have a period of pi. Our domain here, let me erase this. Our domain is all reals except for where we have it being undefined. So x cannot be, notice, pi halves, negative pi halves, all these vertical asymptotes, it's undefined there, right? So we're gonna say pi halves plus pi k, where k is an integer. Another way you could say that is you could just say x cannot be plus or minus pi halves plus or minus 3 pi halves, dot dot dot. Well, I'll do the next one, plus or minus 5 pi halves, dot dot dot. That's another way you could say that. Okay, this is preferred general form. In interval notation, you'd say dot dot dot, negative 3 pi halves until negative pi halves. It's defined there, union, and then we're going to go from negative pi halves to pi halves. It's defined there. But again, I have parentheses on these because I'm not touching the negative pi halves. I'm not touching the pi halves and so on. Dot, dot, dot. Okay, it keeps repeating that. All right, range on this thing. Notice keeps going down, right? It's continuous as it keeps increasing, right? It's increasing throughout. There's no break in your y's. So your range is all real numbers. Y such that y is an element of the reals. Or if you want to do it in interval notation, negative infinity, positive infinity. Your range, all real numbers on this thing. And notice your intercepts. You have negative pi 0, 0, 0, pi 0, 2 pi 0, and so on. You've got these intercepts on this thing. Okay, this is just kind of a nice little graph for that, so on. Now, I don't mind if you guys want to make sure you're doing these by hand so you understand the concepts, and then you can go ahead and check them in like Desmos. I'll pull up Desmos real quick to show you that tangent function. Desmos graphing calculator, f of x equals tangent x, and you can see that there. Right? In fact, we can, if you want, plot a few points with this. We plugged in 0, we plugged in pi 6, we plugged in pi fourths, plugged in pi thirds. We know pi halves was undefined. We could go to the left of 0, so negative pi 6, negative pi fourths, negative pi thirds, and so on. As you're getting all these nice points here, kind of help you graph it. But again, make sure you go through that conceptually, right? As you look at those. All right, let's keep going here. That's enough with the tangent. Let's get tangent functions. Now, all right, the cotangent. So the cotangent is the cosine over the sine. So here we want to think about number one, what's our vertical asymptotes? In other words, where is this undefined? Now in this case, we know that the sine cannot be zero, right? So that we're asking ourselves, the sine of what is zero? Well, we know that the sine at 0 is 0. We know that the sine at pi is 0. We know if we go all the way around, we know that the sine at 2 pi is also 0, right? We know the sine of 0 is 0. We know the sine of pi is 0. We know the sine of 2 pi is 0, and so on. Let me go back to where we were here. So we know x equals 0, right? X equals 0 has got to be a vertical asymptote. We also know that the sine of pi is 0. So pi is another vertical asymptote. We know that the sine of 2 pi is 0. I remember wondering what causes this to be, what x value causes that entire denominator to be 0, right? Right? We haven't even done the negatives, but we could go plus minus on all these, all right? Sine of negative pi, and so on. Let's write the general form for that would just be um, plus or minus pi k, or in other words, well, pi k, where k is an integer, right? That would be all of them. Remember, if k is 0, we got pi times 0. If k is 1, we got the pi. If k is 2, we get the 2 pi. K is 3, we get the 3 pi. Now if we let it be the negatives, if k is negative 1, now we got negative pi. If k is negative 2, now we get the negative 2 pi. So here's the general form for all of those, for that list, right? Okay, so let's put this on a graph here. So what, x equals 0 is 1. X equals pi, 2 pi, negative pi, and so on. Now we're going to plot some points here. Let me get rid of this so I can plot some points. All right, let me go. We'll start out with. Let's go pi halves. The reason I'm going to pick pi halves, I'm right between this vertical asymptote at x equals 0 and x equals pi. I'm just going to split them. I'm going to take that pi halves first because I know the cosine at pi halves is 0. I know the sine of pi halves is 1. So I got 0 over 1, which is 0. So that's an easy point. Let me split them. At 0, I'm undefined. That's a vertical asymptote, but let me split them. I know I can do pi 6. I know I could do, uh, you know, pi thirds and all that, but pi fourths is another nice one because I know the cosine of pi fourths and the sine of pi fourths are the same. So I'm going to get 1 there, right? And then, so pi fourths, got 1. I'm going to pick 3 pi fourths right between those. And what you're going to get is the sine is root 2, cosine is negative root 2 over 2, the sine is positive root 2 over 2, so this will spit out negative 1. And again, you could keep kind of graphing these, put more points on, but what you're going to see is you're going to see that it's decreasing now. Now your period is still a pi amount. It takes your period is pi amount from 0 to pi, right? And it's going to repeat that every time as you plot points. 3 pi halves is you're going to get 0 when you plug that in. When you plug in negative pi halves, you're going to get 0. So anyways, it keeps repeating this. Okay, so if you're looking at decimals on that, there's your pi half 0 and so on, right? See how it's decreasing from 0 to pi, right? Pi is over here about 3.14. I can change this if you want me to. Let me change these. You can kind of see that there. Okay. A nicer little graph than what I got going on there. There's another look at it. All right, now let's tangent x plus half. You know what? Let me stop right here, and I'm gonna make this into a second